This video will recap Lewis structures. Lewis structures are pretty important in organic chemistry as we tend to use them to eyeball the stability of molecules. What I mean by that is we can look at the molecule and gauge certain properties it might have or whether it can or cannot exist. Chemical information tends to be given to us in the form of chemical formulas as it's much easier to transfer this information in text, which is the primary source of our information. This means that we need to be able to convert chemical formulas to their Lewis structures so that we can visualize and analyze the chemical structures. To briefly recap, we will go over the Lewis structure of CH₂O. First, we bond the non-hydrogen atoms together. Next, we add the hydrogens. Different combinations might be available, so keep that in mind. If the valence is not satisfied, you need to form additional bonds. What do we mean by that? I mean, if you have any single electrons that shouldn't be there, try to pair them up. Finally, check your structure to see if the octet rule is satisfied at all times. This was the rule that stated that there should be 8 electrons around each p block atom. Most often, if the octet rule is not satisfied, it means that your structure is not sound, as in it cannot exist as is. However, of course, as in all chemistry, there are some exceptions. The most reliable way to double check your structure is to look back at the periodic table, as we saw in the first video, and seeing whether we have the right number of bonds corresponding to said atom. But moving on. When drawing Lewis structures, it becomes very tedious to draw all the electrons. So therefore, as a shorthand, we can show shared electrons drawn as dashes. So in other words, every covalent bond is shown as a dash instead of 2 dots. Furthermore, lone pairs of electrons should be shown when relevant. This means that sometimes you might show the lone pair, sometimes you might not, depending on the situation. But just because the lone pair is not drawn does not mean it's not there. Hence, you need to be completely aware of this for atoms such as nitrogen and oxygen, whose lone pairs have a lot of chemical activity. Time to practice Lewis structures. Draw the Lewis structure of this chemical formula. I highly suggest you pause the video now because I will show the answer in a bit. Okay, and here is the answer.